Welcome back. So this is the base theorem basically from probabilities. So probability of A given B is equal to probability of B given A multiplied by probability of A by probability of B. That's it. Given that probability of B is not equal to 0, right? So the left hand side is called the posterior. Probability of B given A is called the likelihood. Probability of A is prior, and probability of B is evidence. These are the names that are provided, which will not focus or which will not require during the derivation of naive Bayes algorithm. Okay, this is just for clarity or just for the completion that I have mentioned these names. But this is the Bayes theorem which will be using in deriving the entire naive Bayes algorithm. Okay, so probability of A given B is equal to probability of B given A, means it is going up upside down, right? Or it is just a toggle between B and A, multiplied by probability of A by probability of B. That's it. This is the Bayes theorem. Now here on I'll explain how the naive Bayes algorithm works basically, or what is it that we need to find out. So you see, I'll take a new page. So see, what will be given will be provided with x, right? X will be x1, x2, x3, likewise, right? Let's say xd. So these are the features basically, isn't it? These are the features which are already provided to us. Now, given this, given a particular set of feature, what we need to predict is the class. Let's say the class can be, say ck classes are present, for example. Say C is the class, for example, C is the class which has, say, C1, C2, C3 up to Ck, for example. Okay, so this is K class classification problem, and here we have K classes. If it is binary, then it will be C1 and C2. That's it. Now, given these things, what we need to predict? We need to predict what the class will be. So basically what we need to find out is probability of C given some x. This is what we need to find out basically. Okay, so basically C is Ck. Okay, so let's say we need to find out this. Let's say C equals to sorry, not C, focus here. Okay, so let's say K equals to 2. So this is a binary class classification problem. Then we need to find out probability of C1 given x. Okay, C1 given x, and we need to find out probability of C2 given x. Now what is this x? What is this x? This x is nothing but the prediction of which we want. For example, we want to predict, for example, let's say x, let's write an x like this. So x is, say, sunny, let's say hot, let's say humidity is, say, normal, and windy is, say, true. Now given all these things, we need to predict whether I should play tennis or not. So given some weather, given a weather where the weather is sunny, it is having a high humidity, it is a hot temperature, it has normal humidity, and the windy is true, that is, it is windy outside. So should I play tennis or not, given a data set? Okay, so I'll just show you a data set just for simplification. So let's say this is the data set. Okay, I have already used this data set for explaining decision tree. So this is nothing but 14 days data, and this is outlook, temperature, humidity, and wind. So we have 4 features. Depending on these 4 features, we are basically saying whether I should play tennis or not. This is my class variable. So yes, no, this is binary class. Okay, so given all these 4 features, I have this data already present. Right now, what is naive Bayes doing? At the final stage of naive Bayes, what we'll do is, at the prediction phase, what we'll do is we'll have to simply find out these 2 probabilities. That's it. Probability of C1, that is probability of yes, class yes, given the data point. So this is basically the prediction data point. Okay, the prediction data point means the new data point, the test data on which we want to predict. Okay, this is not the training data. Remember this x is not from the training data, this is from the prediction data. Okay, this is from the test data, this is from the future data which we want to predict. Okay, so this is basically a query point. Okay, so this x, given this x, I'll have to find out the probability of class 1 or class yes. Also, I'll have to find the probability of class no given this data point. Whichever is greater, I will say the prediction as that class. For example, say probability of class yes given x is greater than probability of class no given x. Then what will I say? The prediction is yes, I should play tennis. Done. Otherwise, I will say I should not play tennis. Prediction is no. Okay, so finally we need to find out these two values, nothing else, for a binary class classification. Say the class, it is a 10 class classification. Then we have to find probability of C1 given x, probability of C2 given x, probability of C3 given x, probability of C4 given x, likewise. Okay, up to probability of C10, probability of C10 given x. We have to find out all the probabilities from 1 to 10 for all the classes. For each of the classes, you have to find the probability. Whichever is having the highest value, we'll say that class is the prediction. As simple as that. This is the crux of what we actually are going to do in naive-Bayes algorithm. Okay, this is the final stage. Okay, so we know what the goal is. Now the question is, this particular probability, how do you find? How do you find out this probability? So this is probability of event A given event B, for example. It is in that format. So we can use the Bayes theorem. That is why naive Bayes, right? So in the next video, what I will do is I will show you the derivation of how to find out or how to derive this particular probability using Bayes theorem. Okay, then I will show you with an example. Okay, so see you in the next video. I hope you understood what we actually are trying to do, right? This is our final goal. Now we need to find out how to find this probability. We know what to find. Now we have to do, I'll show in the next video how to find this probability by deriving the entire naive Bayes algorithm. Okay, so see you in the next video. Thank you.